Hello everyone, in this video I am going to teach you how to find the minimum and maximum element from the given linked list. See, now first I will teach you to find the minimum element from the given linked list. Now this is the linked list having 4 nodes. These are the first node, second node, third node, fourth node. Now see, now you should find the minimum element from the linked list. Minimum element is 1. How you can find? That I will teach you. Now the first step is you should create a variable called minimum. This is a variable called minimum which returns the minimum element from the linked list at last. Now see, finally it returns the minimum element from the linked list. Now the default value for this is you should store the data value present in first node. First node is 100, 100's data is 7. So you should store 7 initially by default value. Now see, the next step is you should create a pointer called t. This pointer is used to point towards the first node. So t equals to head, because head is the pointer which points towards the first node. If you write t equals to head, head is 100. So t equals to 100 means it points towards the first node. Now see, now the next step is you should compare the data present in t. Now t is having address 100. 100's data is 7. You should compare whether 7 is less than minimum. Minimum is 7. 7 is not less than 7. 7 is equals to 7. So you should not update the minimum value. Now what you should do? You should move the t pointer pointing to next node. How you can move? See here. Now you should update the t value. T pointer. T should be equals to t next. So t is 100. 100's next is 200. So I am updating it to 200. Then this pointer will point to next node. Now see. Now I should compare the data present in this node. Now 200's data is 5. Now I should compare whether 5 is less than minimum. Yeah, 5 is less than 7. So you should update the minimum value. You should write minimum equals to this 5. That means minimum equals to t data. So I'll update this. Now it's 5. Minimum is 5. Now see. Now I should move the t pointer to next node. So t equals to t next. So t is 200, 200 next is 500. So I am updating it to 500. Now this pointer is pointed towards the node having address 500. Now see, now you should compare the data present in this node. T data, that is 500's data is 9. You should check whether 9 is less than minimum. No, 9 is not less than 5. So you should not update minimum. Now you should move the t pointer to next node. So t equals to t next. So t is 500. 500's next is 700. So you are updating it to 700. So this pointer points to the node having address 700. Now you should check, compare the data present in this node. T data, that is 700's data is 1. Now you should check whether 1 is less than minimum. Yeah, 1 is less than 5. So you should update the minimum value to 1. You should write minimum equals to t data. T is 700, 700's data is 1. You should update it. Now see, now you should move the t pointer to next node. That is t equals to t next. So t is 700. 700's next is 0. So I am updating it to 0. Now the pointer points to the next node. But no node is present after this. So you should stop. See, when you should stop? When the t pointer is having value 0. If it is t pointer is pointing to the node having address 0 means no node is present after this. You have reached finally. Then you should stop. So this is the final. Then after this what you should do? You should return the value present in minimum variable. Now the value is 1. So you can say the minimum element present in this linked list is 1. So this is how you will find the minimum element from the given linked list. Now I will teach you how to write the code for this. See here. Now this is the function which is used to find the minimum element from the given linked list. Now see. Now next step is int minimum equals to head data. What is this? First I have created a minimum variable which stores the data value present in first node. Data present in first node is 7. So I have stored 7 in minimum. So I am writing here, creating a minimum variable which stores the data type integer data type. That is equals to minimum is equals to first data present in first node. First node is represented by head pointer. So I am writing head data, hundreds data 7. So I'm writing head data. So this is the first step. Now see, now next step is you have created a pointer called t which is pointing towards the first node. So I'm writing that, see here, pointer t which is pointing to a node having structure. So I'm writing struct node equals to where it is pointing. The pointer t is pointing towards the first node initially. So I'm writing first node is represented by head. So I'm writing SC here, pointer t equals to head. This is pointer t. This is the second step. Now see, now suppose let's say this is 100. Now this is pointing towards the first node. Now what you have did at starting, now you have compared the data present in this, whether 7 is less than minimum. So that step I am writing, see here, if t data less than minimum, then minimum equals to t data. What is this? See here. Now at starting I have compared whether data present in this 100 data is 7, whether 7 is less than minimum was 7 before. So I have compared whether 7 is less than 7, no, 7 is equals to 7. Suppose see, now this is suppose 200. Now this is pointing here. Now you are comparing the data present in this node, that is 5, whether 5 is less than 7. Yeah, it's less than 7. That's why I am writing the condition t data. T is 200, 200's data is 5. Whether 5 is less than minimum, 5 is less than 7. So what you should do? You should update the minimum variable. That is minimum equals to t data. Now 7 will get cancelled and minimum is equals to t is 200. 200's data is 5. So you have updated 7 to 5. You have updated it to 5. This is the step. Now see. Now the next step is you should move the pointer to next node. How you can move? T equals to t next. So 200's next is 500. So you should update it to 500. Then this pointer will point to next node. So that step I am writing here. See here. T equals to t next. This is the step. Now see, till how much you should do this step. Now again you should compare the whether 9 is less than 5 or not. Then you should update it if it is less than 5 and you should move the pointer to next node. Till how much you should move? See, now you are moving it to next node. So pointer will point to 700. Now again you are moving to next node. You are updating 1. You are cancelling 5 and updating it to 1 and you are moving to next node, that is 0. So till when you should move? Till you should stop this checking this condition when t is equals to 0. So I am writing that condition. See, while t not equals to null. That means what? See, suppose in this case t is equals to null, t is equals to 0. So it does not enter into this condition. It does not compare t data. 0's data, there is no node present here. So it does not compare with minimum. So it stops here. So it travels till this node, till 700. It compares till when this data, when t is 700. So 700's data is 1. So it enters into this condition. Till this much only it enters. When it is 0, it does not enter. So I am writing this condition while t not equals to null. Now see. Now at last, when you have finished, then you should return the anyone present in minimum variable. So I am writing here. Return minimum. This is how you should write the code for finding the minimum element from the linked list. Now see, now I will teach you how to find the maximum element. It is same as minimum but small changes there. See, at starting you have created a minimum variable, right? Instead of minimum you should create a variable called maximum. That is the difference. Now see, I am writing the function. Now see, now I have created a variable called maximum which stores the data of first node. That I am writing same condition. See here. Int. Now same thing, I have created a pointer t which is pointing towards the first node initially. Same thing I am writing here. Equals to null. Now see this condition only you should change. See, at starting you have compared whether 7 is less than minimum, but in this case you should compare whether 7 is greater than maximum. That is the difference, because you are finding the maximum element. So I am changing this condition. See, if T data greater than maximum, if it is greater means then you should update the maximum value. That's why I am writing. See here I am writing, instead of minimum I am writing maximum. Maximum equals to T data. Then what you should do, you should move the T pointer to next node. So same step, T equals to T next. Now finally when you reach the last node, then you should return the maximum value. So I am writing return max. So this is how you should write the code for finding the maximum element from the given linked list. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.